Welcome, curious minds, to another fascinating journey into the heart of manufacturing marvels on how it's made. Today, we're diving deep into the world of rubber, steel, and engineering as we uncover the intricate process of how tires are made. Buckle up, because we're about to roll into the mesmerizing realm of tire production. Did you know that Charles Goodyear discovered vulcanized rubber completely by accident in 1839? And it completely changed the tire industry. His creation led to the development of air-filled tires in the first half of the 1900s. Presently, companies generate about 250 million new tires annually. Amazing, right? Engineers use specialized computer software to create a tire's design before it's authorized for mass manufacturing. Tire engineers can simulate tread design performance and other characteristics with this program. The program computes the impact of various stresses on the suggested design and produces a three-dimensional color picture of a potential tire design. Tire producers can save money by using computer simulations to identify numerous design restrictions before a prototype tire is put together and tested. Upon approval of the design, the company can eventually start production. Now, you might be wondering, what materials are needed for a tire? How are they made? Here it is. 10 to 15 separate parts make up a modern tire, including the pigment known as carbon black, chemical additives, and natural and synthetic rubbers. Rail carriages transport these supplies to the factories where they are stored. Computer systems measure out specific batches of rubber and chemicals and feed them into a Banbury mixer. The Banbury mixer is made up of two intermeshing rotors housed inside a large cylindrical mixing chamber. The rubber compounds are heated in the mixing chamber prior to the start of the mixing procedure. Heat causes the rubber to become softer, more pliable, and simpler to combine with other substances. The rotors rotate in opposite directions as soon as the chamber reaches a certain temperature, which causes the mixing chamber to shear and knead. The rubber and other materials mix together as a result of this motion. Different tire components require different formulae, yet the end product is always gummy rubber dough, which is rolled into sheets by equipment and left to wait for additional kneading and processing. Polyester unrolls into a device known as a calander for the corded ply. The calendar's rollers apply warm rubber to the fabric's two sides, creating the rubberized fabric that will strengthen the tire. Rubber alone cannot create a tire that is robust enough. Hence, this fabric ply is required. Throughout the tire building process, a large number of cotton cords that are spinning off of bobbins are drawn into the rubberized fabric to create channels for air venting. The outermost portion of the tire that makes contact with the road is called the tread. Its distinctive patterns and designs are crafted from a specifically developed rubber compound to provide the best possible grip, handling, and wear characteristics. 3 distinct rubber formulations are needed to make rubber for tread. Extruders shape the 3 rubber streams, and a die then combines them into one. Numerous paint rollers apply stripes of various colors, which helps the factory identify the various ingredients as they are processed. After the mechanism introduces slack into the feed to prevent strain, a blade then cuts the tread rubber to length. Are you ready for the exciting part? At last, every component of the tire comes together. A worker typically places the bead rings on a unique revolving drum to start the tire construction process. The inner liner, a thin layer of rubber that acts as a barrier against moisture and creates an airtight seal, comes next. The corded ply, which covers the inner lining, gives the tire stability and strength. The tire is then filled with beads, and inflated bladders roll the rubber around the bead on both sides. After that, rubber sidewalls are placed on the beads to give the tire flexibility and protection. The sidewalls, which also include various specifications, tire sizes, and brand markings, complete the inner skeleton of the tire. The process of making the outer shell starts with belts being wrapped around another drum. These belts, which are usually composed of steel or other materials with reinforcement incorporated in rubber, strengthen the tire, increase its resistance to punctures, and offer stability when driving at high speeds. The tire design and performance requirements can affect the number and angle of the belts. After that, a computerized system precisely tensions thin rubber ply strips around the belts to create a graded effect. When the ply has the tread applied, the 2 fire fabrications are prepared to merge into one. A transfer ring gathers the outer assembly and moves it to the interior section. Compressed air shapes the tire, which also keeps all of the sticky layers together. An uncured tire without a tread pattern is called a green tire in the industry. A machine rolls the tread rubber's edge over the sidewalls to achieve this. You might be surprised to learn up until 1909, tire installation was manual. The procedure wasn't automated until Goodyear received a patent for their groundbreaking tire building apparatus. Production went from 6 to 8 tires per worker per day to 20 to 40 tires per day, depending on the kind, thanks to this core building equipment, which also sped up the process. To begin the curing process, the green tire is put in a sizable mold. A tire mold resembles a hideous metal clam that opens to reveal a bladder, which is a huge flexible balloon. After the green tire is positioned over the bladder, the clamshell mold shuts, causing the bladder to fill with steam and expand, forming the tire and pressing the raised interior of the mold against a blank tread rubber. The green tire is heated to 280 degrees by the steam during this curing procedure. In addition to molding, the rubber undergoes a chemical reaction known as vulcanization over the duration of its stay in the hot pressurized mold, which changes it from a weak, sticky material to a strong, elastic one. Excess rubber is cut off after it has cured, leaving a neat and tidy tread surface. After that, a comprehensive inspection is performed on the tire to look for any flaws or irregularities. To guarantee both safety and quality control, this step is essential. Hundreds of tires are removed for destructive testing at the end of the production line when a new tire design is being produced for the first time. To find air pockets between body plies, some tires are cut open and others are rubbed against metal studs to gauge their resistance to punctures. Others are tested for mileage and other performance attributes by being spun quickly and pressed down onto metal drums. Tires go through extra finishing procedures after passing inspection and testing. These include putting on a layer of protective coating, identifying the sidewalls with tire characteristics and brand names, and adding any necessary branding or labeling. After that, the completed tires are packaged and ready for distribution. They're usually kept in warehouses until they're sent to car makers or dealers. Isn't the entire process mind-blowing? If you found this episode as gripping as the treads on a fresh set of tires, don't forget to hit that like button, subscribe for more captivating How It's Made content, and leave a comment below on what you'd like to see next. Until next time, stay curious, stay informed, and keep rolling with How It's Made.